merge sort. So we have taken an array named ARR, which consists of 8 elements. The lowest index has been stored in L, that is 0, and the highest index has been stored in H, that is 7, right? So we would need the services of two functions basically as far as merge sort is concerned. One is known as the divide function, which works recursively to get this array divided, and later on we'll see how the function merge works, which basically not only merges the array but at the same time sorts the array, right? So let us get started as to how this divide function or the merge function work to get this array sorted. So for the first time when this function would be called, it would be called with the arguments of ARR, which is this array, and the lowest and the highest indices, which are currently 0 and 7. When we say 0 and 7, it means the whole array, or we are taking the whole array, right? So let us go into the code of this divide function. The first if condition is if L is less than H, which is true at this point of time, hence control would go within the if, and it would calculate what? M, right, as L plus H divided by 2, low plus high divided by 2. That means it is finding the midpoint of the array concerned. Array is this, the concerned array at this point of time, right? The whole of this array. So what would be the midpoint? Midpoint would be 0 plus 7 divided by 2, which would be 3.5. But since index cannot be a float or a real number, it is only going to be a integer number. That is why we would be declaring this M, or it has already been declared as an integer. So it would be storing only the integer part, which is 3. So 3 is our answer as far as the middle point of this array is concerned. That is this index. As you can see, 0, 1, 2, 3 would be our first sub array, or the middle point is this, and on the left hand side you have one sub array, and on the right hand side you have another sub array consisting of elements 2, 9, 1 and 8 being represented by the indices of 4, 5, 6 and 7. The other sub array of course is being represented with the indices of 0, 1, 2 and 3, right? So after calculating mid or the M, we have a function call to the same function. That is why we will be doing the recursion as far as this divide function is concerned. It would be doing things recursively, or there would be recursive calls to the same function again and again. In the meantime, we would be calling also the merge function. So you will have to keep track of everything and look carefully how we are going to call these functions at different points of time. So let us continue. So as far as this divide call is concerned, this is the second call, this being the first. So when control will go to this if block and it would reach this instruction, it means that I am calling the divide function again with the arguments of ARR. Of course, that is this array, and now the parameters would change. L would of course be 0 again, but H, this H, it would be passed with M, right? So what was M here? M is 3 here. So I would be calling this divide function with ARR comma 0 comma 3, right? So I have shown it here that I am calling another function since it is being recursively called. So I'll be calling this divide function again, but with the parameters of ARR and 0 and 3, right? ARR is this ARR again, or the array itself, and L and H would be now 0 and 3, right? Right? What does that in turn mean? That means we are currently concentrating on this sub array whose lowest and highest indices are being represented by 0 and 3 respectively, right? Right? Of course, this array would remain as it is, but for understanding purposes, I have taken out this sub array to show certain things that would be seeing shortly, right? So again would be checking if L is less than H, and I would be calculating M, the midpoint of this time, the midpoint of this sub array, right? What would be that? Low plus H, 0 plus 3 divided by 2, that would be 1, right? Right? And I would be going to this divide function again, but this time with the arguments of ARR 0 and 1. Right, that's what I have written here. That means this divide function has been called with the arguments of ARR 0 and 1. What does that mean? As we saw in case of this subarray, this means when L and H are 0 and 1, it means that I have taken another subarray out of this parent array which is now being represented by the lowest and highest indices of 0 and 1. So this would be my 0th element and this would be my 1th element, right? So recursively we are reaching stages, right? Now if L is less than H, yes, of course it is less than H. So I would be calculating M again. This time M would be 0 because 0 plus 1 divided by 2 is 0, right? As I said earlier, we are only concerned with the integer part. So not 0.5, but M would be 0, right? What next? Next, we will go to this function call. This time with the arguments of 0 and 0, because L is 0 and M we calculated as 0. So this function call would be with those parameters 0 and 0. Now, what does that suggest? That suggests I am talking of the sub array, if I can say it, with the indices, low and high indices of 0 and 0. Doesn't that mean this only element or the solitary element? Right. Now concentrate on this. So we have called this function for the first time from the calling function. If we can repeat things, then we had gone from this point to this function call, reached this point. It created another function call which took us to this function, and at this point we created another function call or made another function call to this function. Now concentrate on this, since control would now go to this point. If L is less than H, this time it is false because L is not less than H. So control won't go inside this function. It would be returning control back to where the control came from. So control came from this point. So it is done because its job is done, right? So the control would shift to the next instruction, right? Which is this, which is again the divide function being called, but this time with the arguments of M plus 1 comma H. What was M here? M was 0. So 0 plus 1 would be 1. And of course H is 1. So this call would be, divide function call would be with the parameters of 1 and 1. Don't you think that is this element 7? Because it is the element 7 whose index is 1. So lowest index 1 and the highest index is equal to 1 means this solitary element, right? Now should control go inside this? If no, because L is not less than H. So the call would be returned, or the control would be returned to the point where it came from. That means this point. And since it is all done now would be moving to the next instruction, which is the call to a merge function, right? The merge function. So with the arguments of ARR, of course, L, M and H this time round, if I can show it here. So what is ARR? ARR means this array, lowest index means 0 and the middle index means 0 and H is 1, of course. So what are we up to basically? We are basically up to this, that we will have to merge these two elements. Up to the stage where we reached, we had the two solitary elements from this array, which is 3 and 7. Now it is the turn, after doing some splits, it is the turn now to merge them. So your question would be, what was the fun of doing all this when we return to that point where we had already 3 and 7? The basically the idea of, or the function of the merge function is to not only merge the elements or the sub arrays, but at the same time sort them. So since 3 and 7 are already sorted, they would be kept as such. But suppose if it would have been 3 and 1, so 1 would have come here and 3 would have come here, right? So it would have been 1, 3. So for the moment, since they are already sorted, no changes would take place as far as their order or the position within the parent array is concerned, right? Right. So the detailed code of this merge function would be discussed later on. For the time being, you just remember that this function, when called, merges two sub arrays and sorts them at the same time. Do you think that 3 and 7 are two sub arrays? Yes, they are, even though they consist of only the one elements, right? So what next? Next, the control which was here at the merge function, it would be now returned. Where? It would be now returned to this point from where the call came from. This having already done because all the work associated with this function call has been already done. So the control would move now to this part, or this divide function call, but this time with the arguments of ARR m plus 1. Now remember, m here was 0 plus 3 divided by 2, that is 1. So 1 plus 1, that is 2, and h. H is of course 3. Right? So this call would again be checking that if L is less than H. Then before doing that, let me show you when your indices are low and high indices are 2 and 3. It basically means the sub-array, this sub-array, which has the lowest index of 2 and highest index of 3. Right? As we have been learning all along the previous function calls. So when L is 3, H is 3, that means we are talking of the sub-array whose lowest index is 2 and highest index is 3. What if here, if it was L was 3 and H was 8, for example, not in this case, in general. So that would have meant that we have a array whose sub-array is being considered currently with the lowest index of 2 and highest index of 8, or whatever I talked of the values of L and H. Right? So currently we are here the sub array with the lowest index of 2 and 3. That is what is being shown here. Now the control would go to this if block if L is less than H is true at this point of time. So we would be calculating what? M. So M would be calculated as 2 plus 3 divided by 2, which is 5 by 2, which is 2. Right? So the function call would now be made to divide again, right, with the arguments of 2 and 2. Why? Because low is 2 and M we calculate as 2 comma 2, right? What does that mean? That means the solitary element with the index, lowest index of 2 and highest index of 2. Or simply to put in simpler terms, it means that the element with the index 2, which is 5, right? Right? But control would not go to the if block at this point of time because L is not less than H, so its job is done. I would be moving control to the next instruction, which would call the divide function again, but this time with the arguments of m plus 1, that is 2 plus 1 and 3, because H is 3. 2 plus 1 is 3 and H is 3. So 3 comma 3. What does that mean? That means this element with the index of 3 comma 3, or the index 3, right, which is 4, right? L is not less than H, so control won't be continuing. Instead it would be returned to this point where from the call came from. Having done this, now the control would go to the next instruction, which is to merge the arrays, right? So you guessed it right, just like we did in case of 3 and 7 to get it merged to a sub array of 3 and 7. Now we would be combining or merging these two sub arrays into a sub array with these two elements. First, let's have a look of what the arguments would be. It would be ARR, L would be 2, M would be 2, and H would be 3. Now remember here the first sub array consists of the indices, or it starts with 2 and it goes up to M. Very important here. It starts with 2 and goes to 2. The next sub array, this is a general formula, so it applies to this also, and we'll be seeing later on also that whenever you call the merge function, this index represents the lowest index of the first sub array, and this represents the highest index of the first sub array. Now M plus 1 represents the starting address or index rather of the second sub array, and H represents the highest index of the second sub array. So I would repeat for you. L represents the lowest index of the first sub array, M represents the highest index of the first sub array, M plus 1 represents the lowest index of the second sub array, and H represents the highest index of the second sub array. So this call would simply merge these two. And as I said previously also, that this merge function that we'll be seeing in later part of this video, that this 5 and 4 has now become 4 and 5. So they have been sorted also, as I said earlier also, that this function not only merges sub-arrays, but at the same time sorts them also, right? So we have reached a point where we have taken care of the left side or the left sub-array of this parent array, except for one more step that would be checking. So for the time being, let us say the job of this merge function is done, and the job of this instruction has been done, and this function has been done. So we have reached to the previous function call, or the point where from the call was made. Having done it, now the control would go to merge function again, this time this merge, right? So what would that be doing? That would be doing the merging of two sub arrays with the indices starting index of 0 and 1 for the first sub array, and 2 and 3 for the second sub array. You can check that out here, right? So for this sub array, I will have the starting index of 0 and highest index of 1, while as for this sub array, second sub array, you will have the starting index of 2 and highest index of 3. So that is what we have done here. So as I said already, that I have merged these, but at the same time what, sorted them also, and thereby I have taken care of this function call also. Now if you remember that this function call was made out of this, right? So this is done. Now we have reached to this point, right, from which the first call was made to the right. So any guesses what should happen now? Yes, this is done. Now control would go to this part, right? So it will be going to this side, right, or the right side. So now the divide function would be called with the arguments of m plus 1. What is m? M was 3, if you remember. 0 plus 7 divided by 2, it would be 3. 3 plus 1 is 4, and h of course is 7. So that's what I have written here. L is 4 and h is 7, right? L is less than h. First we will see that the concerned array would be this much, or this right sub array, right? Now the control would go to if L is less than h. Yes, this time the condition is true. So m would be calculated as 4 plus 7 divided by 2, which is 5. So a divide function would be called again with the arguments of what? 4 and 5, right? That is what I have written here, 4 and 5. That means these two elements with the indices of 4 and 5, right? Now the control would go to if it is again true, because 4 is less than 5, m would be calculated as 4, right? Because 4 plus 5 is 9. 9 divided by 2 is 4. So another function call would be made from this point with the arguments this time of 4 and 4, right? Because L is 4 and m we just calculate as 4. That means we are talking of this element, or the solitary element with the index of 4. So this time this function control won't go inside if, so control will be returned back to this point, which would initiate the execution of the next step, which would call the divide function again with the arguments of arr. M plus 1, m is what? M is 4, I guess. 4 plus 1 is 5 and 5. So 5 and 5, that means this element, the element with the index of 5. Again control won't go inside this, but instead the control will be returned to this point, which would be done also. Now we will be executing this merge function, this time with the arguments of 4, 4 and 5. So my first subarray would be with the elements of 4 as the lowest index, 4 as the highest index. Next subarray would be 4 plus 1, that means 5, 5 as lowest and highest indices, which are these two elements. They would be merged. Since 2 and 9 is already sorted, so no changes done to their order. Right now control would go back to where it came from. That means this point, and it would now go to the next point. Next point we are calling the divide function again with the arguments of m plus 1. M here is 5. 5 plus 1 is 6 and 7. 6 and 7. That means these two elements, 6 and 7. Right? 6 and 7. This is true. M would be calculated as 6. right? So we'll be calling this function, divide function, again with the arguments of 6 comma 6. That means this element, sixth element, control won't go inside. If instead it would be returned to this point. Now the function would be called, divide function would be called with the arguments of 7 comma 7, because m is 6 plus 1 is 7, and this h is already 7. So what does that mean? That means we are talking of this element, right? So then what we'd be doing is that this part is done, this is done, control would go here, it would be merging this time. What elements? 6th and 7th elements, which are these two elements, and they would be merged as 1 and 8, no change in their position because they're already sorted. Now this is done, this is done, control would go to this point, this is also done. Now control would reach here, would be merging what? Would be merging two sub arrays with the indices of 4 and 5 and 6 and 7. That means this and this and this and this, or this subarray or this subarray. So it would be sorted as 1, 2, 8, 9. So massive change as far as their positions are concerned. Right, now having done this, right, so we have reached to a point back to where we came from. This is already done now. So now the control would lastly reach to this merge function, which would simply call the merge function with the arguments of 0 and 3 and 7. So my first subarray would be 0 and 3, and the second would be 4 and 7. That means these two subarrays, so they would be merged. So now it is the time to see in detail what merge function basically does. So I'll be discussing this merge function in the context of these two subarrays. So I have this subarray with the indices of 0, 1, 2 and 3, and this second subarray which has been assigned the indices of 4, 5, 6 and 7, right? So what basically merge function does is it compares elements from this array with the elements of this array, of course one by one at a time, and assigns that value, if it is a smaller one, to this merged array, if I can call it, right? As I said earlier also, that would be doing things in the context of this array. So it is just for understanding purposes that I have created this so to say a hypothetical array, but things would be basically taking place with respect to this array. So let us not confuse ourselves for the moment. So we will assume that this array, subarray, and this subarray are being merged to form this subarray, right? So we would be taking up 3 and comparing it with 1, right? And if the element from this subarray is smaller one, that is assigned to the current position of this array. Otherwise the element from this array is assigned to this array, right? So to keep track of the positions or the indices, let us say we have assigned I as an iterator for this subarray and j as an iterator, which will be keeping track of where we are currently at this as far as this array is concerned. So j would be taking care of that, and k would be taking care of where we are currently at a particular point of time with respect to array 3 or this merged array, right? So to start with, as would be seen code just shortly, I would be 0, j would be 0, and k would be 0. I is equal to 0 means we are currently at this index, or the value concerned is this, which is to be computed, and j is equal to 0 means we are currently at the first element as far as array 2 is concerned, and k is equal to 0 means that I am currently at this first positions. I am basically awaiting to the value which would come either from this array or this array, right? So what should be our code? If ARR1's ith element is greater than ARR2's jth element, then ARRK's element would be either this and this, right? So in this case, if it is true, ARR1's ith element would go to this place, else ARR2's jth element would go into this, right? So compare 3 and 1 would go here, right? Now one more important thing is the element taken from whichever array, the iterator of that array is incremented, right? So what I mean to say is that if I am assigning this array an element from this sub array, then I would be incremented. If it came from this array, then j would be incremented, right? So when we compare 3 and 1, 1 is smaller, 1 would be going here, and j would be incremented because element came from this sub array, right? So now 3 and 2 would be compared. Again 2 would win the comparison and 2 would go to the merged array, right, or this array. Now 3 remains there because it has not 1 in the previous 2 attempts. Now 3 would be compared with what? 8. 3 would now win the comparison. 3 would go here. Now 4 would be compared since 3 is done. Now incremented element, or we have reached this element 4 would be compared with 8. Again 4 would win. That means element from array 1 would win. Now 5 would be compared to 8, right? So 5 would win the comparison, so we'd be assigning 5 here, and next 7 would be compared with 8, so 7 would be assigned to this array, right? Now since we have expired this array, this is very important here, since we have expired this array, that means we have no elements left in the array 2, array 1 rather. So the rest of the elements of the array 2 or the sub array 2 would be assigned or taken out one by one and assigned to this array, right? That is why I have taken 8 here and put it here, 9 here, because these arrays, since they are already sorted, so if I took all the remaining elements and assigned them to this array, they would be sorted as well, or in turn the whole array would be sorted. That is what I have shown here. Now so the procedure has been finished, right? So the function merge, what it does has been explained, but let me tell you that the same thing would have happened when we have merged these two arrays to form this. So in that case, this would have been array 1, this would have been array 2, and this would have been the array 3. So this state is the final state of this array. So it is not a separate array. That is what I was saying to you. So at the end of the day, we would have this array which is a sorted one, and that is what we were striving for. Now over to the detailed code of the merge function. As you can see, it has been passed with ARR, L, M and H, right? So the limit for the left subarray or the subarray 1 would be M minus L plus 1. So you can check out things with reference to these two subarrays, right? So N2 represents the number of elements in the left subarray or the subarray 2. So it would be calculated as H minus M. Then we are declaring two arrays, left and right, with these two limits or the number of elements that we just calculated. So in this case, the example that we just explained here, so N1 would be 4 and N2 would be 4 because both came out to be equal to 4. Now 4, right? So we'd be declaring L with 4 and R with 4. That is 4 elements each. Now what remains is we will be basically initializing this left side array or this L. So what do you think that left subarray should be initialized with? Yes, 3, 4, 5 and 7. That is what this for loop does. And this for loop does what? It assigns the values of 1, 2, 8 and 9 in right subarray, right? Then as I said earlier also, that I would be taking care of the index of this subarray, left subarray. J would be taking care of the index of this at different points of time, subarray 2, and K would be representing the index of this array, right? So then what we say is that while there are elements in the array 1 or the left subarray, and there are elements in the right subarray rather, till then we'd be comparing the element from the left subarray with the right subarray, and accordingly we will be assigning the value from the left subarray or the right subarray to the third subarray, that is this, right? So this while loop would end when one of the subarrays would expire. That means there are no more elements to compare with, right? So when one of the arrays is expired, that means there are no more elements, then we'll put its elements into array. This array, it can be either the left subarray or the right subarray, right? So that's about it.